All right, in this lesson, we're going to take a look at using a graphing calculator to find extrema, and we'll talk about what extrema are also. Just as a note, you will need a graphing calculator for this. If you do not have one, there are lots of graphing calculators that you can use online. The one that I will be using so that I can show you on the screen is at graphcalc.net, and it works just fine for graphing functions and just being able to look at them, which is what we need for this assignment. Okay, so let's first talk about what are extrema. Okay. Well, the extrema are the maximum and minimum points on a graph. You have two different types. You have a local minimum, which is just a point that's lower than any other point near it. And then you have what's called an absolute minimum, or global, some people call it, which is the very lowest point on the graph. So minimums are low, maximums are high. So again, a local maximum is higher than the points to the left and right of it. And an absolute maximum is the very highest point on the entire graph. Okay. In your questions, you're asked to use a graphing calculator to graph the function and then approximate the local absolute extrema for that function. So let's take a look. I'm going to pull up my graphing calculator. This is the function I'm going to be graphing. Okay, so you get your graphing calculator ready. We're going to be graphing x to the fourth minus 4x to the third minus 7x squared plus 22x plus 24. Okay, so I'm going to pull up my graphing calculator now, reset it so that I have a blank window, and then up here at the top I'm going to type my function in. Now if you're using an online calculator, for exponents you put the little caret button, so that would be x to the fourth and then minus 4x to the third minus 7x squared plus 22x plus 24. And then I just hit enter and it graphs my function. Now notice one thing I notice when I'm looking at this is I'm trying to find the high and low points on the graph. And if you look up here at the top of my graph, I'm missing part of it. See how it goes up and comes back down? I need to know where it peaks. So if that happens and you're not seeing the lows and the highs of your graph, make your maximum and minimum values for your x's and y bigger. So the minimum's just fine. I don't need to change that because I can see the bottoms of these. But I do need to change the maximum. Let's put it at 30 and see if that's high enough. You'll see I still can't see the top of my graph. So now I'm going to change my maximum y value. You want to be changing the y's for the ups and downs. I'm going to change it to 40. Okay, so see now I can see the top here and the bottoms here, and I'm guessing these just go upward forever. So now I have a pretty good spectrum. So what you want to do is make sure your trace is on. Okay, so right now tracing is off. I'm going to turn it on, and what that allows you to do is to see where points are on your graph. See these numbers, see the x equals and y equals down there. When I go up on the graph, it has numbers. For example, right here, x is negative 1.6 about, and y is negative 6. That allows me to identify points more easily than having to guess where they are using the scale. Okay, so again, we're supposed to identify local extrema, so maximum and minimum points on the graph. So anywhere the graph turns and changes direction. So notice here, this point is lower than all the points near it. Okay, when we come up here, this point is higher than the points near it, so that would be a maximum. And as I keep going, here's another low point, another minimum. So we have 2 minimum points and 1 maximum points. Now so far they count as local minimum and local maximum here. What would make them an absolute maximum or minimum is if they are the very lowest point on the graph or the very highest. Now notice my maximum point up here. It continues going upward, the graph does. So it's not an absolute maximum because there are points higher than it on the graph over here and over here. Okay, so it's just a local maximum. Here, this is a local minimum. This is a local minimum, but notice they're also the very lowest points on the graph. Nothing goes below that. So these would be also absolute minimum points. Okay, I'm going to close this down so we can answer our question. I'm just going to go to the next slide. So here's a picture of what my graph looks like. So let's take a look at it again. We want to identify maximum and minimum points for our graph. Okay, so a maximum point I had was right here. See how the graph hits a peak right there? It's higher than all of the points around it, so that's a maximum point. And you would just use the trace function on your graph to find where that is. So I go up to the top, and then down there, notice it says x is about 1 and y is about 36. So I have a maximum point at 136. Okay. Minimum points were down here and here, so again I'm going to use the trace to find out where those points are exactly and just kind of estimate. That's all we can do here. So that looks like about negative 1.5, negative 6.1. And then we had another one over here, so again let's trace and find out where that point is located. It's at about 3.5 and negative 6.1. They look like they're about in the same place. Okay, so about 3.5, negative 6.1. Okay, now let's decide, are they absolute or just relative? The maximum is just a relative maximum because it's higher than the points around it, but again, it's not the very highest point on the graph. Here and here, the graph continues upward, so it's not the very highest point, but it is a high point. Okay, these are absolute minimums. And why is that? Well, they're relative minimums because they're lower than the points around them, but they are also the very lowest points on the graph. Nothing falls below that. Okay, so we graphed and found our extrema. Okay, so that's one shape